Hello everyone, today we are solving Candies problem on Hakerrank. In this problem, Alice is a kindergarten teacher and she wants to give candies to her children depending on their performances, and as an input we have an performance array in this problem and each element represents the performance of each student. To give candies there are some rules. Each student should get at least one candy, and if a student has higher rating than the adjacent student like this student should get higher number of candies. For example, if we give one candy for the first student, the second student should get one more candy than the previous one because his or her rating is higher than the previous one, and the third student has less rating than the previous one, so we can give one candy for the student. But the fourth student has less than the previous one. This time we should give less number of candies to this student, but we cannot give zero. We should give at least one candy. So what are we going to do in this situation? We should update our array tracing back like this. For each step we are not going to update array for each iteration. First we will create a temporary array and we will update fix it at the end. How are we going to create our array at the beginning? First of all, for example, if our first student value is 2, we give 1. At the beginning, all conditions we give 1 for the first student, and we check for the second student and we compare it with the previous one. When we compare it, second is higher, so we give 2. We gave 1 more candy, and the third one has less value than the previous one when we compare, so we give 1 to this student, and the fourth student has 2. This should be less than 2. But less than 1, but we cannot give less than 1. We should give at least 1. So we give 1 to this student, and the rest should be updated, but we will update it later. And we go for the next student. Here our latest element in our array is 1. So if we check the next element, it is less than the previous one. So again we cannot give 0. This time we will again give 1. But we will update this later. And we go for the next element. 7 is higher than 1, so we should give 1 more candy like this. And 8 is higher than 7, so we should give 1 more candy from the previous one. 9 is higher, so we give 1 more as 4. And 2 is less than 9, so we can give 1. There's no problem. But when we go for the last element, 1 is less than 2. But we cannot give 0 again in this situation, so we should give again 1. And we created our temporary array. Now this time we should update it. We should fix the problems because we cannot give same number of candies for different number of performances. For different performances, this student have to get higher number of candies than this student. To compare this, we should use reverse function because we will check our arrays from end to beginning, and we will compare our performance array with the temporary array like this. Here is our array, and there is a mistake here. This should be like this. Yes, here is our performance array and this is our temporary array, and this is our solution array. This is the desired solution, and at the end we should return the sum of this array. But how are we going to get this? We get our temporary. To get this, we compare our performance array with the temporary array, and for each iteration we get 2 values and we compare them. If in our performance array the second element is higher than first element, I say first element because we assume that we reverse this array and we begin from end and we go through the beginning of the array. So this part is the beginning of this array when we are comparing them. So if our first element is less than the second element and if the values in the temporary array are equal, we should increment the second element of this array by 1. We add 1 to previous element and we give this value to our result array, our temporary array, and we go for the next couple. 2 is less than 9, and again in our temporary 2 is less than 4. There is no problem, they should be both less. 9 is higher than 8, 4 is higher than 3, no problem. 7 is higher than 8 is higher than 7, 3 is higher than 2, no problem. 7 is higher than 1 and 2 is higher than 1, no problem. But this time 1 is less than 2, so this element should be less than this element. To make this, we should increment this by 1. So we get the value of this element and we add 1 to this and we put it here like this. Here 2 is less than 3, but 2 is not less than 1, so we should update this one. Let's update it, incrementing the previous one by 1 like this. 3 is less than 4, so 3 should be less than this element, so we should make it 4. We add 1 to this element and we updated it. When we compare this desired solution and our fixed temporary array, we see that we get the same arrays. So at the end we return the sum of these arrays. First of all, to solve this problem, we create a result array, and at the end when we get our result array, we will return the sum of this array. But if our result is empty, what should we do? We should return we should return 0 if our array is empty. If it is not empty, we will return the sum of this array. And how are we going to find this result? First of all, we should iterate our performance array with each with index method in Ruby, and this method will give us a value and an index like this. When we finish our iteration, we should close our each with index method like this. And if our index is equal to 0, first of all, we should give 0 for the first element of our result array, or if our when we are checking an item, we compare it with the previous item. So if our previous item is higher or equal than our current item, we should add 1 to our result. If it is not higher or equal, if our previous item is not higher or equal than our current item, this time we should add our result like this. But what are we going to add into our result? We will increment our previous item, so we should get the previous item like this, and we increment it by 1, and we put this result into our array this way. Okay, by this way we created our temporary array. So we should check and compare it with our performance array, but we should get their reverse versions. So we initialize any variable with the reverse function of the Ruby. Let's create a performance array, and it also is the reverse of our current performance array. And this time we will iterate our results with each with index method. And for this method, this will also give us a value and an index, and we can close it like this. For this problem, if our arrays next element, because we go from back to front, and each time we compare our current element with the next element. So if our next element is higher than our previous element, our current element, if our next element is higher than our current element, and if our next value of our temporary array, so we get it like this, is less or equal than the current element of our array, we should update our array. So to update it, we should update our next element. So we get our next element like this, and we should put this value to it. We should increment our current value by 1, and we should, like this, we should update, increment our current value by 1, and we update our next value with this one if our next element is less or equal than our current element in our temporary array. But we should also check the index value for the edge cases. So if our I is less than r dot size minus 1, for each time we should check this, because for each time we check for the next element, if the next element is nil, we can get error. So I think this is also okay, and at the end we get R1. This is our updated array, but this is a reversed version of our result, so we should use reverse again to update our result like this. Let's check our problem. If there's no problem, if there's no typo, we will run our code. Or let's run our code. If it gives an error for us, oh, there's no error, then we can submit it. Yes, we passed all the test cases. It's a bit long problem. It was a bit hard to explain. I don't know if I explained or not. But that's all for this Candies problem. See you on next challenge.